Hello, my name is Eric, and this is my lab study on black holes and orbits. So, to begin, let's discuss some key fundamental physics principles. So, every equation here is derived by Newton's second law, where F is equal to ma, and the second equation is the gravitational force, where F grav is equal to negative g, big M, little m, or r squared times r hat. And this just describes the attractive force between two body of masses. And the next equation would just be the F net, and it's equal to the F net in the perpendicular and the parallel components. And these allow us to find change in direction or the change in velocity of an object. And lastly, we have the position and update formulas on the bottom, from lab 1 and 2. So, the purpose of the experiment in part 1 was to write a code to determine the mass of a black hole, whereas in part 2, the goal was to determine an initial velocity where the spaceship could go around the planet and moon in a figure 8 alignment without crashing. For part 1, this is the code I used. Um, this is my initial conditions of gravity, our mass, and throughout this code, as you can see, was used to find the velocity components, and then this was used to find the momentum, and then this is the change of velocity and change of momentum, and then using Newton's second law, I was able to find, or the overall net force, and then by doing that, I was able to calculate the change of momentum in the parallel, right here, and then I was able to find the perpendicular net force, and then by doing this at the end, this is the equation I was able to use to find the mass of a black hole at a certain given point. And the way my code worked is every time it ran it, I added that value to an initialization right here. And similarly, I added like the amount of times it ran the simulation right here. And by doing this, I was able to find like the total amount and divided by the total like amount of times the simulation ran, which is right here, which would allow me to like average the masses and find, I guess you could say, the mass of the black hole. And by doing that, I was able to find the mass of the black hole to be 1.405 times 10 to the 34 kilograms. And in my system, the system is a star and the surroundings is a black hole. And as you can see in the video, as the star gets closer to the black hole, the arrow vectors get bigger, but as they go away, they get smaller. Just because as it gets closer, gravity has a greater effect upon it has a greater force. So it'd be bigger in magnitude. And then for part 2, we had to find the initial velocity of what's it called, a spaceship. And it was mostly by trial and error, but these are my initial conditions I had given. And my initial x was 2.85 e to the 4, my initial y was 2.58 e to the 4. And then on this side, this is just simply finding the radius and velocity position of everything. So here, I was able to find the force from the planet on the moon by finding the radius and r hat, and this is the gravitational force equation right here. I did that the same thing for the ship to moon force, and then I was able to find the net force on the moon by adding the two forces together. And similarly, I found the net force on the ship by finding the force from the planet to the ship, and by finding the force from the moon to the ship. And then by doing this, I was able to find the velocity and position of the moon and ship by using the velocity update formula and the position update formula right here. And this is what my code ended up running. And as I mentioned before, my initial velocity was 2.85 e to the 4 in the x direction and 2.58 e to the 4 in the y direction. So let's discuss some possible errors. So in part 1, I assumed there were no outside external forces acting upon the spaceship, which in reality wouldn't be entirely accurate. And in addition, I may have just had some coding errors which could affect the results. Somewhere in there might be something that's swaying the results. And then in part 2, like as I said, the initial velocity was determined by trial and error, so the figure 8 could vary depending on what you choose. And as I said, mine looked like this. And for the first question here, net force is a change in motion, and it's the sum of all external forces and directly changes the object's motion, and it's found by adding all outside forces. And the change of momentum is found by knowing the change of velocity, The parallel components equal tangential velocity, and perpendicular components lead to change in direction. And for question 2, a code would have to have all forces of gravity acting upon each other, such as this black hole, star, planet, moon, all upon each other to find and predict the motion. And since a black hole has the greatest mass, it would be the dominant gravitational force in that code. Thank you.